This is a Cambridge IGCSE Chemistry Paper 4 Theory Extended Paper talk through from 2021. The table shows the number of protons, neutrons and electrons in particles A to I. Answer the following questions about particles. Each letter may be used once, more than once, or not at all. State which of the particles A to I is an anion. So an anion is a negative ion, which means it must have more electrons compared to protons. So you do need to have a look down here. So far we don't meet that criterion of having more electrons than protons. Keep going, and then you can see that E has 2 more electrons compared to protons, so that is the answer here. What about our cation? So we need 2 answers here. Positive is a cation, so we need more protons this time. And as you look down, you can see that we have more protons for A. Then keep scanning down, and more protons for I. Next up, we need noble gas atoms. And so because they're noble gases, it means they have a full outer shell of electrons. Make sure you're happy with what all these things mean. So in order to do that, we're going to write out the electronic configurations using these numbers here. It's worth taking the time to do this. We can tick the ones which do have a full outer shell, but be careful, we only need 2 answers, and the key word here is that they're atoms, which means they're not ions, so they have to have an even number of protons and electrons, which is why E isn't the answer, but D is the answer, and then G is the answer, but I isn't. Is a halogen atom, which means it needs 7 electrons in the outer shell. So this one's more straightforward. It's F. Is a group 1 atom, so 1 electron in the outer shell. You can see that that is H. Have the same nucleon number. So remember, the nucleon number is the mass number. So we can actually go down that and work that out, because remember, the mass number and the nucleon number is the total number of protons and neutrons. So 1, 12, 14, 20, 32, 35, 40, 39, 40. So which of those numbers are the same? It's G and I, with a mass number and a nucleon number of 40. Causes acidity in aqueous solutions. Remember, the acidity is caused by the hydrogen ion. So it's the element with 1 proton, so it's A. Is used to define the relative atomic mass of elements. Remember, we compare them all to carbon-12. So carbon-12, that's its mass number. It has 6 protons and 6 neutrons, which you can check in the periodic table, so that's B. Explain why B and C are isotopes of the same element. Remember that isotopes have the same number of protons, but a different number of neutrons, as agreed by B and C. The elements shown are gases at room temperature and pressure. State which one of these gases is green. It's the halogen, it's chlorine. It's a green gas at room temperature. The gases shown exist as diatomic molecules. State the name of another element which has diatomic molecules and is a gas at room temperature and pressure. So they want an element. These are all diatomic, H2, N2, O2, Cl2. We want another element, so a halogen is a good one to choose here. Needs to be a gas at room temperature, which is why we can't choose bromine or iodine. It has to be fluorine. When separate samples of each of these samples are placed in a container, they will diffuse. Describe why these gases will diffuse, because they have random motion. State which of these 4 gases has the highest rate of diffusion and explain your answer. So what you need to do is check your MRs for each of these, and you're looking for the one with the lowest MR, which is hydrogen, because it's the lightest gas and therefore it will diffuse the fastest, but we can't write that it's lightest, we need to say it has the lowest. MR is the simplest way of saying that. Nitrogen, oxygen and other substances are found in clean, dry air. State the percentage of nitrogen in clean, dry air. It's actually 78%. Other than nitrogen and oxygen, identify another element found in clean, dry air. So we can't talk about water vapour or carbon dioxide because we're after an element. Let's pick argon, which is a noble gas. Identify a compound found in clean, dry air. Again, we can't use water here because the air is dry, so we're going to say carbon dioxide. Nitrogen and oxygen can be separated from liquid air. State the name of this process. It's fractional distillation. This question is about ammonia. Nitrogen reacts with hydrogen to form ammonia in an industrial process. Name this industrial process. It's known as the Haber process. State the meaning of the symbol. This means that the reaction is reversible, goes both in the forward and reverse direction. State the conditions used in this industrial process, include units. So we need a temperature of 450 degrees Celsius and a pressure of 200 atmospheres. So lots of rote learning for this question. Name the catalyst used, it's iron. If the pressure is increased, the yield of ammonia increases. Explain why in terms of equilibrium. So to consider the effect of pressure, we need to count the number of moles of gas on each side of the equation. We've got 2 moles on the right-hand side and a total of 4 moles on the left-hand side. When you increase the pressure, it will favour the side with fewer moles of gas, shifting the equilibrium to that side, and in this case, shifting it to the right in favour of a higher yield of ammonia. So we're going to say there are fewer moles of gas on the right-hand side. Therefore, the position of equilibrium shifts to the right. If the temperature is increased, the rate of reaction increases. Explain why in terms of particles. So this is a collision theory answer. So particles have more kinetic energy. Therefore, there is an increased frequency of successful collisions per unit time. Ammonia reacts with sulfuric acid to make a compound which is used as fertilizer. Write the chemical equation for the reaction between ammonia and sulfuric acid. There's the formula of ammonia. H2SO4 is the formula of sulfuric acid. And then we're going to be making ammonium sulfate fertilizer. The charge on the ions is this, which means you need 2 ammonium ions. Pop it in brackets. And then we need to balance it. Just check. 2 nitrogens here, 2 here. 6 hydrogens, 8 hydrogens on the left-hand side, 8 hydrogens on the right-hand side, 1 sulfur and 4 oxygens. We're all good. A student wanted to make some zinc chloride crystals. The student followed the procedure shown. Add excess zinc powder to dilute hydrochloric acid to form aqueous zinc chloride. Remove unreacted zinc powder from the aqueous zinc chloride. Heat the solution until it is saturated. Allow the saturated solution to cool and remove the crystals that form. Write the equation for the reaction. Step 1 includes state symbols. So we know we've got zinc powder, it's a solid. Hydrochloric acid is an aqueous solution. We're making zinc chloride, just to show you why that's the formula. You've got Zn2 plus Cl minus, which is why you need 2 chloride ions. And we're making the gas H2. Don't forget your state symbols. And then just make sure it's balanced. We need a 2 here. We've got 1 zinc, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Explain why excess zinc powder is added in step 1. That's to ensure that all the hydrochloric acid reacts. So Suggest how unreacted zinc powder is removed in step 2. It's a solid. The easiest way to get that out is by filtering, so filtration. A saturated solution is formed in step 3. What is meant by the term saturated solution? It's a solution that can dissolve no more solute at a given temperature. Explain why crystals form as the solution cools. This is all to do with solubility decreasing when the temperature decreases. Name 2 zinc compounds that react with dilute hydrochloric acid to form zinc chloride. You could use zinc oxide and zinc carbonate. If excess calcium metal is used instead of excess zinc powder in step 1, pure calcium chloride crystals do not form. Explain why. The problem here is that calcium is pretty reactive, so it actually reacts with the water. Some salts can be made by titration. In a titration experiment, 20 centimeters cubed of aqueous sodium hydroxide reacts exactly with 25 centimeters cubed of 0.1 molar dilute sulfuric acid to make sodium sulfate. Circle the name of the type of reaction that takes place. So if you were to write an ionic equation of what's going on here, it's actually a hydroxide ion reacting with a proton, H+, to form water, which is a neutralization reaction. Calculate the concentration of aqueous sodium hydroxide using the following steps. Calculate the number of moles of dilute sulfuric acid used. This is the formula triangle you need to use. So number of moles is concentration times volume. So we know that we have 0.1 moles of sulfuric acid. The volume was 25, but make sure it's in decimeters cubed. So divide by 1,000 to get 2.5 times 10 to the minus 3 moles. Determine the number of moles of sodium hydroxide that will react. Just check the mole connection up here. It's 2 to 1, so we just have to double that number we found in the previous step. So it's 5.0 times 10 to the minus 3. And then calculate the concentration of sodium hydroxide. So we do concentration is number of moles divided by volume. The volume was 20. Get that into decimeters cubed again by dividing by 1,000. Our answer here is 0.25. And then lastly, calculate the concentration, but this time in grams per decimeters cubed. The way you do that is by doing your concentration previously, but then you times it by the MR of sodium hydroxide because you're doing it grams per decimeters cubed. So we take that 0.25 and multiply it by the MR of sodium, which is 23 plus 1 plus 16 to get 10 grams per decimeters cubed. The table shows the names or structures of organic compounds P to U. Give the letters of the organic compounds P to U that are unsaturated hydrocarbons. That means they contain C double bond C and only hydrogen and carbon atoms. So if I actually draw the displayed formula for these other ones, we'll be able to work this out a lot more easily. Here's propanoic acid. Here's butyronine. Propan-1-ol. It's an alcohol. I won't draw all the hydrogen bonds, but you get the idea. Methyl butanoate. I'll come back to that one. I'm going to struggle to fit it all in there. But give the letters of P to U that are unsaturated hydrocarbons. So we're looking for an alkene. So it's R and U. Describe the test for an unsaturated hydrocarbon. Remember, you add bromine water to it, and it should turn from orange to colourless. You need that colour change. And that's proving the existence of that C double bond C. Butanene is an unbranched molecule. Name the unbranched isomer butanene. So it's an isomer, so it has the same molecular formula but a different displayed. We don't want it branching, so actually let's just move that double bond along a carbon so it becomes butuene. Draw the structure of a branched isomer butanene. Show all the atoms and all the bonds. So we need that methyl group showing because that provides the all-important branching. And remember, our molecular formula we need to obey is C4H8. Just check. 1, 2, 3, 4 carbons. 3, 4, 5, 6, 7, 8. Yes, always double check. And I've shown all the atoms and all the bonds. Dodecane is an alkane with 12 carbon atoms. Dodecane can be cracked to write the formula of dodecane. So here's our general formula. So N is 12 here, and H is 2 times 12 is 24, plus 2, 26. Give the letters of all the organic compounds that can be formed when dodecane is cracked. So we need a mixture of alkanes and alkenes that have a shorter length of carbon chain. So P is relevant, R and U. Name the reagent and suggest the conditions needed to convert organic compound U into organic compound S. So we're going from U to S, so we're taking an alkene and turning it into an alcohol. This is a hydration reaction, so you need steam in order to do that. You could talk about a temperature of 300 degrees or a catalyst, it's up to you. Organic compound S can be converted to organic compound Q by reaction with an acidified reagent. Name the type of chemical change that happens to organic compound S. So we're going from S to Q, so an alcohol to a carboxylic acid. This is an oxidation reaction. It happens naturally. Microbial action on wine will turn it into vinegar. But they've asked us for the acidified reagent, which is potassium manganate 7. Organic compound T is made by reacting two compounds together. Name the homologous series that organic compound T belongs to. It's got a very distinctive name here. It's an ester. Name the two compounds which react together to make organic compound T. Draw the structures of each compound you've named. Show all the atoms and all the bonds. So, with esters, remember the first bit of the name comes from the alcohol, and the second bit comes from the carboxylic acid. So in this case, we have methanol and butanoic acid. Let's draw them. So meth means one carbon atom. There's the OH alcohol functional group. We've shown all the bonds and all the atoms. Butanoic acid means 4 carbons. There's the carboxylic acid functional group. And now complete the molecule with hydrogen atoms. Deduce the molecular formula of organic compound T. Okay, so I'm going to have to draw it actually. Methyl butanoate. Looks like this. Draw it super carefully. Make sure you count your bonds. Each carbon atom needs 4 bonds, hydrogen 1, oxygen 2. And then because it wants the molecular formula, work out how many carbons you've got. 1, 2, 3, 4, 5. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many oxygens? 2. I'm just going to remove that because that isn't the answer up here, but I was using it to help me work out the molecular formula. Polymers are large molecules built up from small molecules. State the name given to the small molecules from which polymers are made. Those small molecules are known as monomers. The formula of a polymer is shown. Draw the structure of the small molecule from which this polymer is made. Show all the atoms and the bonds. So the monomer, remember, you need to reintroduce that double bond. And then just be careful, it's asked for all the bonds. And then just double check, each carbon atom has 4 bonds. Yeah, that's correct. So we remove these bonds here. State the type of polymerization used to make this polymer. It's actually addition polymerization. You're just adding them together. 3 amino acids are shown. They combine to form part of a natural polymer. Name the type of natural polymer formed when the amino acids combine. These are proteins. Complete the diagram to show part of the structure of the natural polymer that forms when these 3 amino acids combine. Show all the bonds of the linkages. So remember, every time they join, you end up with a bond that looks like this. So we just need to make sure we keep repeating that. So at this end, it will look like this. Then that linkage I was just talking about. Then another one here. So draw that really carefully. Each nitrogen forms 3 bonds, carbon 4, oxygen 2, hydrogen 1. Name the type of chemical reaction that takes place when this natural polymer is converted back to amino acids. That's actually hydrolysis, which is the addition of water.